Hey Flight Simmers, welcome to a new episode on my channel on the Airbus A320 home cockpit build. As you can see, the overhead panel is still under construction, but I just finished the redesign of the Cory switches and I'm currently preparing a little video series about the redesign of the Cory switch and especially how to design your own custom-made PCBs that's located in the new Cory switch with the switch and the LEDs, resistors directly mounted on the PCB. It's much easier to assemble and much quicker as well. So, like I said, I'm currently preparing a series about it. In the meantime, I will continue with the pedestal. In the last episode, we did the assembly of the parking brake, and in today's episode, we will focus on the design of the speed brake. This is my design for the speed brake. As the real speed brake and the real Airbus cockpit, it has the same functionality. You can pull the lever to extend or retract the speed brakes, and in the retract position you can pull the lever up for arming the ground spoilers, and in this position it's locked until I put it back down, and then the speed brake can be used again. How does it work? It's based on my panel template I'm used several times for the overhead panel. Underneath there's a little mechanism that controls the speed brake lever. So there is this little swivel axis in the middle that swivels around the axis. It's limited by this little 4mm rod in this curved slot, and in the end position it's the only position where it's allowed to pull it up, and in this position you can see there's a little toggle switch on the side, and this lower end stop is engaging the toggle switch, pulls it up, and when you push it back down the toggle switch is released. On the side there's a little drivetrain for the potentiometer. I'm using the potentiometer to identify the current position of the lever. And this is a great example on how to design more complex assemblies in Autodesk Fusion. As you will see later, I'm not designing this in one single file. This time I'm using some sub-assemblies like the swivel axis in the middle and the drivetrain on the side. This will be individual sub-assemblies because I want to reuse this design for the flaps and maybe for the gear lever as well. So it totally makes sense to create sub-assemblies and reuse it in other designs. This is the longest video in this series, but if you want to get more into Autodesk Fusion, especially on how to handle much more complex assemblies in Autodesk Fusion, and especially on how to approach it, how to divide it in several groups or sub-assemblies, it's definitely a video for you. I will also show you how to use joints in assemblies. We used joints previously in positioning all the components in the overhead panel, but joints are much more powerful than that. You can use them, of course, on connecting several components together, but you can use joints as well for the design process itself. You can use it for checking for any collisions if you just move the joint in your Fusion assembly, or you can use the joint or the limit of the joint in the design process itself. For example, this curved slot the opening angle is defined by the limit of the joint of the lever. So a great example for how to use joints in Autodesk Fusion. All the printing data is already available for my supporters on Patreon. If you want to support this channel, please consider joining the community on Patreon and on Discord. If you're new to the channel, please subscribe and hit the bell. But now let's go into Autodesk Fusion and do the design of the speed brake. Before we start with the design of this assembly, it's always a good idea to have some initial thoughts before we begin with the design. This is the old assembly for the Speedbrake, and I did some very bad design choices in here. There are no joints between the individual parts, and the organization in the design tree is not really good. So this time I want to enhance it a little bit in the design perspective. But before I begin, it's maybe a good idea to think about to divide it in individual sub-assemblies. So in this design tree, all the components are designed in this assembly. And this time I want to create some sub-assemblies. What could be a sub-assembly? For example, the swivel axis in the middle with the top and the bottom end stop and the middle section over here. And then the drivetrain for the potentiometer could be a sub-assembly. So the two gears, the potentiometer and the mount for the potentiometer, this could be a sub-assembly, and then one main assembly that holds the panel, the sub-assemblies for the drivetrain and the swivel axis, and the two walls on the left and the right side. I already started a new design document, the swivel axis, and in here I want to create the middle section and the two end stops and the tubes that are connecting the end stops and the handle as well. So this whole middle section will be one sub-assembly. Go to the swivel axis, and in here I'm starting with a global sketch. I want to create the main contour as a global sketch because I need this profile for the top and bottom end stop and the middle section. Just draw a slot, center point slot from the center to the right. The length will be 30 and the width is 15. Then I need 3 holes in there with a diameter of 6, and I'm using some equal constraints just to match the two remaining circles to the first one. So when I change it, all 3 circles change the size. And this is my main sketch. And now I want to create the individual components, and for this I'm creating new components. Let's start with the middle section and with an extrusion. This extrusion will be .24 millimeters. So an extrusion, this profile, symmetric, distance 12 millimeters to both sides, so 24 in total. This is the first section. Then I need another sketch on the front plane. The inner circle is 20 for the axle later on. And the spacing is 1.5 millimeters. let's begin with the ring with an offset of 2.5 millimeters. And -20 join. And now let's cut the hole into the part all the way through, like this. Okay, now I have this hole is missing, so I have to cut it again. Symmetric. All right, and give it a fillet, 5 millimeters. Okay, the two holes in the middle has to be changed to 8 millimeters. Now it's 6 millimeters, and for this I'm using a press pull, both of the faces, and -1. And now it's radius 4. And I open up the two 6 millimeter holes as well, just by 1/4 of a millimeter to 6.5 millimeters. Later, the two connecting rods between the top and bottom end stop has a little bit of space to the walls of the two holes in the middle section. You will see it later in the assembly. So 8 millimeter in the middle and 6.5 on the outside. And now this part is almost finished. If you want to, just add some chamfers on the top and the bottom face. And now this part is finished. Let's create another component. Let's start with the top end stop. It's pretty simple. Just this profile, 10 millimeters. And open up this center hole, -1.25. So it's 8.5 millimeters in diameter to have a little gap between the rod and the middle. Okay, some chamfers, again, 0.25 millimeters. And this end stop is finished. And one more end stop. The same profile, 10 millimeters. And in here, all the three holes are 6 millimeters. You will see in a minute when we adding the rods in the middle, how it's connected, all the components with each other. So now for the lower end stop, I need a hole from the side, just 4 millimeters. And I just projected the profile of the drilling hole in the middle, because on the right side I need a little boss to the side. From the center to the outside. 27.5 millimeters. And an extrusion with an offset of negative 7.5 millimeters. Symmetric. Three millimeters. Like this. Add some fillets. And chamfers on the bottom and top face. And all three parts are done. But now you see they're overlapping and not really in place right now. And now this is the place where we have to add some joints or constraints. Let's switch off all the sketches. Okay. Well, all three parts are not fixed in space. If you press the Alt key and select one part, you're able to move it. And you can move all three pieces. And as soon you're moving one of the pieces, you get two new symbols. You can either revert the position or you can capture this position. Now you have a new symbol in the timeline. This position is captured. We will come back to the capture of positions later on. So for now, I just delete it. And I'm dragging the two end stops. Okay, both of the end stops are pulled aside. Now I'll capture the position anyway to have some space, because now I'm in the global component. I'm creating a new sketch as a construction line and just a circle. It's my reference for the first joint I'm creating. I want to set the whole of the middle section onto this circle. And for this, we'll use a joint, and we have used joints on several occasions when placing components in the panels or the labels. And now let's have a closer look on the joints. There are basically two types of joints, joint and an as-built joint. An as-built joint, we come to that later, but the joint is really powerful. We haven't used it so far, but you can do some really crazy things with a joint. And we need two components. The first component is the circle of the inner hole of the middle section, and the second is the circle I just draw on the sketch, and I give it an additional offset of 10 millimeters to the left, so it's right in the center. The origin of my whole assembly is right in the center of the hole. And you can define a motion. And for this type, for this part, I want to have a rigid type. I don't want to be able to move it. Now I've assigned a joint, and when I press the Alt key, I'm not able to drag it anymore. It's fixed in space, but the two end stops are still movable. Let's switch off the sketch. And now I have to create a joint or a constraint between the end stops and the middle section. Let's have a look on constraints first. We already used constraints in sketches. So in sketches, you have the constraints, tangent, equal, parallel, and so on for lines and circles. But you can define constraints between several components as well. Let's try it. Constraint component. I need a geometry. For example, this hole should be aligned with this hole. Okay, and now when I drag the part, it's revolving around this hole. But it's still movable. I want to give it another constraint between this and this hole. And now I'm just able to move it up and down. These are constraints, and I could add another constraint between the bottom face and the top face of the middle section. But now it's fixed. I'm not able to move it anymore. Back in the constraint, you can open it up like any other of the features in the timeline. Give it an offset of 10 millimeters, for example. And you have this offset. But I want to have it movable. I want to move it up and down until it collides with the middle section. So delete all the constraints, because when you're using constraints, you can stack the constraints. So the first constraint between these two holes, and then I can add another constraint between this component and this hole. And now I have just one constraint in the timeline, but this constraint holds two sets of constraints. And to identify the collision between those two parts, I can use a contact set. Enable contact sets. Now you got a new entry in the design tree, and you can create a new contact set. A contact set between this end stop and this part. And now you can move it around upwards, but as soon you're colliding with the part, it will stop. I'm not able to push it into the part. These are contact sets. I just notice it's basically the bottom end stop. It should be on the lower side, but I'm not able to drag it through the middle section. I can do it just by disable the contact sets, and now I can drag it through the part, go back and enable the contact sets. And now this is right. Okay. One more contact set. Not a contact set, constraint between these two holes. Add another constraint. All right, like this. The middle part is 24 millimeters. I want to have a travel of 10 millimeters. So I can add another constraint between the two surfaces and give it an offset of 34 millimeters. Now the spacing is right, but I'm able to pull the upper end stop into the part. And for this reason, I'm creating a new contact set, the upper end stop to the middle section. And now it's limited the travel of the two end stops. Okay, this is the assembly with the usage of constraints and contact sets. The disadvantage of contact sets is that they're getting lost when you're dragging or pasting this sub-assembly in a main assembly. Then all the contact sets are gone. And for this reason, I want to show you another solution to set up this assembly. Let's go back to okay. Now I've removed all the constraints. And now I want to use some joints. Go to Assemble, Joint, and create a joint between this circle and this one. If I hit OK, it's in the right location, but I'm not able to drag it because I set it as a fixed or a rigid joint. But I can change it to several types, revolute, then it will just spin around the hole. You see the animation, that's just a preview. You can change the axis of the rotation, but a rotation is not what I want to have. I want to have a slider. And you can already see in the preview, I can slide it alongside the x-axis or y, z, or change any other line as the axis, but I will use the z-axis. And now I'm able to set some motion limits, minimum, maximum. Let's set the minimum of -10 and preview the limits. It's the wrong side, okay. Set it from 0 to 10, preview the limits. All right, this looks much better. Hit OK, and now I'm able to drag it, but just the 10 millimeters I set in the limits. And with without any contact sets, I limited the motion to 10 millimeters. And these limits will stay even if you're pasting the sub-assembly into another assembly. So you should always look for joints and use constraints just when necessary with the contact sets. So I always prefer the joints over the constraints. Now let's add another constraint, another joint, this hole, but now not to this one, but to this one, and give it an offset of 34 millimeters. The motion type is rigid. When the lower end stop moves, the top end stop is moving as well. And because of the limit in the bottom end stop, the top end stop will stop when colliding with the part. This is a much better solution with the joints and the joint type as a slider than the constraints and the contact set. Okay, now I want to capture the position. Now the bottom end stop is completely downwards. Okay, and now I need some rods. Let's start with the 2 rods on the side. 6mm outer diameter for on the inside. Give it some equal constraints. And create two bodies to an object to the top face of the top end stop. New body, okay. Now when I go back to the main component, I'm able to drag both of the rods aside. But now I want to revert the position. So back in the location where I designed them. And they are already in place. So this time you could either use a joint and pick the two positions, but the position for the rod and the second position inside the bottom end stop, it's the same position. So if you have this situation where the component is already in the right location, you can use an as-built joint between the rods and the bottom end stop. It's rigid, and now when I move bottom end stop, both of the rods will follow. Okay, this is the first rod. Let's add another one. Go back to this sketch and add another 6mm tube. Just noticed that I made it. No, I didn't make a mistake. Okay, just 100mm upwards. Maybe it's a little bit too long, but for now I don't care. So this tube will pull. The handle is mounted to this tube, and when I pull the handle, it moves both of the end stops upwards, and this little boss on the side will trigger the toggle switch. All right, and then I need one more 8mm tube right in the middle. I will create it in the main component. Two circles. The outer one is 8mm. The inner one 6. Create an extrusion. To object top face of this rod, but with an offset of 20mm. Let's give it a test. Pull the rod. The 8mm tube stays in place. And the outer rods will follow the end stops. That's pretty nice. When we have section analysis, You can see there's a little gap between the outer rods and the middle section. Now I see the rod I created in the middle. It's operation type join, but I want to have a new body. Like this. And I did it with this as well. New body. All right, now the swivel axis is actually complete. There's a little 4mm pin missing in here to connect the 6mm tube, but I will skip it. For now, this swivel axis is complete and we are able to go on with the next sub-assembly, which will be the drivetrain for the potentiometer. I'm starting a new design file, rename it to potentiometer drivetrain, for example. And I will use this drivetrain again for the flaps. So it's a very good idea to have it in a separate design file, and we are able to use it in the flaps again, and it's not necessary to design it one more time. In here, the potentiometer drivetrain, I'm starting with the large center gear. And for the gear, I'm using a utility add-ins, and in here I'm searching for gear or spur gear. Just by press this play button, it opens up the spur gear add-in. We used it in the episode before when we designed the parking brake. And in here I add the number of teeth. I will set it to 50 with a module of 0.8. The module defines the size of the individual teeth, and it's basically just the pitch diameter is the result of the number of teeth divided by the module. So it's 40 millimeters. The backlash, it's a little bit of space between the teeth. I set it to 0.1 millimeter. The root fillet radius, currently I'm getting an error. The root fillet radius is too large. Set it to 0.2 millimeters. Now the error is gone. The gear thickness, I will set it to 6 millimeters, and the hole diameter to 6 millimeters too. And now just press OK. And here is the gear. This gear is movable because it's not, as it has not any joints or constraints. So I'm able to move it, revert the position. And in this case, I ground it to the parent. I don't want to move this large gear. Go back to the top plane. And I want to create some pockets in this gear just to save some material. For this, make it active, the spur gear. Go back to the solid tab and create a sketch on the top plane. And in here, I'm creating a line over here. Keep the it doesn't work. Okay, just 2 lines like this. Create an arc, center point arc from here, first endpoint, second endpoint. Add some dimensions. Like this, to finish the sketch, create an extrusion with this profile, add some fillets, maybe a little bit too large, 1 millimeter is totally fine. And now I've created just one pocket, but I want to have 4 of them. But now I'm just creating a circular pattern. Object type features, so select the extrusion and the fillets, select the axis and the number of copies, set it to identical. Okay, one more thing to this gear right in the middle. I want to create a polygon. Vertical constraint on the side. Oh, 12 is a little bit too large. Set it to 10. And one more extrusion. And if you want to, create a chamfer, top and the bottom face, 0.25. In this case, because of all the teeth, it takes a while to create the chamfer. Now it's done. Okay. Now the first gear is finished. We need another one for the potentiometer. But before I create this gear, I'm creating a global sketch. Right on the top plane. Okay, the first spur gear with the 50 teeth. Let's go to the first sketch because this is the first. It's a third sketch. Here you can see the pitch diameter. This is very important. It's 40 millimeters. So this diameter, please keep it in mind, 40 millimeters. It's important in a minute. Now let's create the second spur gear. Go back to the Utilities tab, open up the add-ins, select for gear and start the spur gear add-in. In here, we have to use the same module as for the large one, otherwise it wouldn't work. Number of teeth, set it to 15. Pitch diameter is 12. Keep that in mind as well. 40 and 12. And the rest is the same. The backlash, a little bit of space between the teeth. Root fillet radius, gear thickness, and the hole diameter is 6 millimeters. The axle of the potentiometer is 6 millimeters as well, so it will fit on the potentiometer. Hit OK. And there is a gear. I can drag it around. That's totally fine. And now I want to create a joint between this fillet, this gear and this one. And I give it an offset in the Y direction. And now it's important to have the 40 millimeters and the 12. So I need 40 plus 12 is 52, and half of it is 26. Like this. Now the teeth are not aligning, but I don't care right now. But I set the motion type from rigid to revolute. I want this gear to be able to move around this inner spur gear. Later, it's important to have it movable later on when we are placing the potentiometer on the part. It could be in the center, or we could rotate it to any direction or any spot around the inner spur gear, for example, to the left side, just where I have enough space. Okay. And now, as you can see, I created a joint with a revolute. Now you have this little flag in the middle. When you double click on it, you can define a value for the rotation. Just escape. Now it's okay as it is for now. So the second gear is done, almost. Make it active, and in here I want to create a chamfer 0.25. Okay, now I'm going to my templates. And in the templates, there is my potentiometer folder. And in there's already a potentiometer template. I made a full episode for the potentiometer. So I'm using this one again, but this time without the knob. I don't need it. So make it invisible. I just need the potentiometer. And I'm creating a joint between this circle, this one. And again, I want to have a revolute type of joint that I'm able to revolve the potentiometer later on when placing it into the assembly. Hit OK. And now when I drag the gear, you can see it spins around, and I'm able to rotate the potentiometer. Okay. Now just revert the position. And last thing, for the sub-assembly for the drivetrain, I need a holder for the potentiometer. Create a new component. And a part holder. I'm starting with the construction of a midplane. Select both of the faces of potentiometer, and right on the midplane I'm creating a sketch. Projecting the lower contour of the potentiometer as a construction line. And now I'm drawing a profile, something like this. Give it some constraints. Start with horizontal and vertical constraints. I need a coincident constraint between the upper line and the lower face of the potentiometer, and some dimensions, the thickness 2 millimeters. the overall height from the top face of the large gear to the bottom of the holder is 15 millimeters. 15 millimeters in width, and now all black, all the lines are black, they're fully defined. Drawing 2 more lines. Just to give it a little bit more strength. And just drag the end point. No, I can't grab the end point. 10 millimeters. Okay, create an extrusion of this main profile. Direction symmetric. Let's make it 10 millimeters. There are 2 reinforcements from this object, 2 millimeters, and create a mirror of this feature. And the mirror plane is the construction plane we created earlier, and the compute type, set it to identical. All right, there's the hole missing in the holder. For this, I'm just creating a combine between the holder and the potentiometer as a cut operation. Create a press pull just to enlarge the hole in the middle a little bit. And the same with this little pocket. I even want to just cut it all the way through. Create another sketch on this face. We need a slot for a screw. Create a slot, center point slot, right from the center point, the radius of 2.25 millimeters. I want to use an M4 screw. And just a length of 4 millimeters should be enough. Create an extrusion. Add some fillets. And some chamfers. Okay, go back to the main component. Now what's very important, this holder is not connected to any of the other components, so I have to fix it. In this case, simplest solution for this is a S-build joint, again, because this holder is right in the right position related to the potentiometer. Just make a motion type rigid. And now when I pull the small gear, the potentiometer and the holder will follow. And when I move the potentiometer, when I rotate it, go to the relationships, here are the joints, it's a second revolution, drive joints. Now the potentiometer and the holder will follow. Revert the position. And now the second sub-assembly is finished. And we can go on with the main assembly. Don't forget to save the sub-assembly. Hit OK. All right. Let's open a new design document. This will be my main assembly. Browse to the folder and the pedestal, Speedbrake, not in the sub-assemblies anymore. Speedbrake, assembly V3. I will rename it after the full assembly is done. I will delete the Speedbrake assembly V2 and rename the Speedbrake assembly V3 just to Speedbrake assembly. But for now, it's just V3. And what do we need? Of course, we need a panel. Drag it in from the templates. I don't need the stands. Break the link because I want to change the size. So this one, '89 by 149. Yes. Go to the Modify tab, change the parameters. The width 149. Oh no, I forgot that dimension. 89. This panel can be moved, but I want to have it fixed in my main assembly. Right click and ground to parent. Now it's fixed. And all the other components will be connected to this panel with the usage of either constraints or joints. Before I will drag in the sub-assemblies, I will create some planes first from the right side. 45 millimeters from the right side. This will be the plane where the sub-assemblies are connected to. So the dimension from the right to the center of the slot. I'm using a plane because later on, when I noticed that something is wrong, I just move the plane and every sub-assembly will follow just this plane. Create a sketch. Create projected geometries as a construction line. The lower and the bottom face of the part, or you can just select bodies and create a projected geometry of these two bodies. You can just switch the visibility of the panel off and have just the construction lines. Create some more construction lines from the center. downwards. I'm creating a circle, diameter 20. And a construction line, an angle of 25 degrees, and this angle will later be used to limit the travel of the whole lever. So later on I can just modify this value to have either more travel in the handle or less travel. So this one is a very important sketch in this whole assembly. I need another dimension from the top to the bottom, 50 millimeters, and I will change the dimension in a minute, because now I'm able to use this sketch as a reference for my sub-assemblies. Go to the YouTube folder, pedestal, Speedbrake, and the sub-assemblies. I will start with the swivel axis. Well, that's the wrong one. No, I forgot to save the swivel axis. Go back to the Speedbrake assembly. Now I get a notification. Yeah, and now there is my swivel axis. And I'm creating a joint between this hole and this circle. Flip it if necessary and give it an offset of 10 millimeters. And now it should be right in the middle. And rotation of 270 degrees. Okay, I will come back to the joint in a minute. Just have a look. Okay, now the swivel axis is in the right location. I'm able to move it, and I'm even able to spin it around the center hole, what it's supposed to be, but I did it by accident. Let's have a look in the joints, the motion, yeah, and there is already the revolute type along the z-axis. When I set it to rigid, it's not possible to rotate it around this center hole. Go back to the motion, set it to revolute along the z-axis, and now here I can set the limits, 25, 25, okay. All right, and now you can see that I have a collision between the upper end stop and the bottom panel. So that's the reason why it's very useful to have the full motion in the sub-assemblies. Otherwise, in this case, in the low position, it would be fine, but in the upper position, I have the collision. But to fix it, it's very simple. Go to the sketch and change the value in height to 60. And now I have enough clearance to both sides There's no collision anymore. Okay, revert the position just to the center. I don't need the sketch right now, so make it invisible. Don't forget to save. Okay, and now I could create the first wall that I will mirror later to the other side. Create a new component. Wall left. I need some projected geometries. Yeah, first of all, I need a sketch, of course. And this time I'm not using the construction plane. I will go directly onto this outer surface of the middle section. And in here I need some projected geometries. 20 but change the filter to specified entities. This 20mm hole, the lower edge of the bottom panel, and this lower hole in the bottom end stop. Hit OK. Okay, and now I'm creating the first half of the wall. Just set the dimensions. I need a circle. And create an extrusion with this profile. Well, let's go back to the sketch. Okay, this is the large radius from the swivel axis. Yeah, the outer one, but I need the inner one. And 5mm upwards, like this. Okay, this is the first half of the wall, but it's not finished yet. I need an extra pocket for the ball bearing I'm using, and a slot for the end stop. Let's do this next. Let's project this geometry again as a construction line. And create a slot, but in this case a center point arc slot. But don't forget to set it as a regular line. (25°). Now I'm setting a fixed value of 25 degrees. There's a huge an issue with this one. I'll show you in a minute. Let's just finish the slot Set it to a radius of 2.25 millimeters. Finish sketch. Create an extrusion. Okay. Now in this case, I limited the travel of the swivel axis to 25 degrees. So this should work just fine. But when I go back to the joint of the swivel axis and change the motion and increase the limits from -30 to +30, in this case, I would not have the right slot as an end stop because I set it up to 25 degrees in this sketch. To fixing this, I will not use this value over here. Let's go back. Let's drag the timeline back before I created the sketch. And now I'm moving this joint in here. Go to the relationships, joint, this revolute joint, drive joint. All the way to the end stop, 30 degrees. And in here, I want to capture the position. You can either do it by hand. Otherwise, when I go back to the sketch, it will lose the position. So it's very important to capture the position, 30 degrees, capture. And now when I go back to the sketch, the swivel axis is in the end stop position. And in here, I'm just creating another projected geometry as a construction line with this hole. Hit OK. And now here's the circle. Just drag it, this one, onto this one. If it doesn't work, just create a coincident constraint. And now finish the sketch. Now, of course, drag the timeline behind the second extrusion. And now when I go back to the joint and change the limits back to -25 and +25, it will recalculate the whole part with the captured position at the end stop, and the slot will be modified automatically. So it's a very nice feature. All right, let's make the sketches invisible and mirror this one to the other side. But before I will do this, I will create the mounting hole on top. Create a sketch over here. All a polygon. Some dimensions. The circle is 4.5 millimeters. I'm using the M4 screws. I use a lot in this project. Let's start with the boss. To 10 millimeters. Now there's one contour missing. Go back to the sketch. And with an offset of -0.5. 5 millimeters. Maybe with 6, a little bit more space. All right, and now the nut will fit into this part. I will close the pocket with some hot glue and then just mount it from the top with a M4 screw. Okay, maybe fillet over here, 2 millimeters. And now just create a mirror plane, this plane, identical, but don't select features, select the whole body, join. All right, and all what's missing is the slot that I'm able to pull the lever upwards. So create another sketch. And create a slot, center to center. With a tangent constraint. And set the length to 11 because I have set it in the end stops to 10 millimeters and I just want to have a little bit more travel just in spare. Okay, create an extrusion, cut it to the body like this. All right, before I'm adding the little boss on the side for the toggle switch, I will mirror this wall to the other side. Because now everything, oh no, the pocket for the ball bearing is missing. So one more thing, sketch on this side, and I'm using a ball bearing with a diameter of 27 and the thickness is 4 millimeters. Okay, and now I can mirror this wall to the other side. Create mirror, this one, mirror plane over here. Okay, this looks pretty nice, but I'm able to move this whole assembly with the two walls. To solve this, just create an S-build joint between these two components, rigid, and now both of the walls are fixed. All right, now let's move the swivel axis to the other side. This is the location where I want to have the toggle switch be placed for the for engaging the speed brake. Set it to negative 25. Capture position, otherwise it will lose this position. In the next step, go back to the wall. Create another sketch. And in here I need a little extension. Create a center line like this. Now let's make it a little bit more accurate. Project the geometry of this boss, of the lower end stop. And now just drag it onto the center point. Now it's right in the middle. Okay, and maybe we have to give it an offset to the left, creating a point over there, and then a circle with a slight offset, 1.5 millimeters. Okay, like this. Create an extrusion. I'm I'm in the wrong component. I should set it to, or create it in this component over here. So just drag the sketch into this component, and we don't have to create it again. Create some fillets. And now we need a toggle switch. For the toggle switch, just follow the link in the description. There you'll find Fusion export file for the toggle switch. It's free to download. Just go to File, Open, and then the toggle switch mini. Open, and in here there is already the complete assembly of the toggle switch, including the joint for the lever. So in here you can toggle the switch. Just open the Fusion export archive and save it to the templates. Now let's go back to the Speedbrake assembly. And in this left wall, I'll keep it as the active component. I drag in the Toggleswitch Mini, then this Toggleswitch will be placed inside this wall. Create a joint. Flip it if necessary, like this. And the motion, I keep the motion along the Z-axis just to modify the orientation of the toggle switch. And here I'm rotating the toggle switch around 25 degrees. And now the lever is in the bottom position, so I have to move the lever downwards to the end position, capture over here. This looks pretty nice. Let's move it upwards, and this one as well. But now you can see I have to reposition the whole toggle switch. Go back to the sketch. I'm deleting this constraint and do it manually. Set it to 31. This looks okay. It's still not enough. A little bit backwards, 34. So it's a little bit of trial and error. This looks much better. Okay, like this. But as you can see, the boss could be a little bit longer to reach all the way into the toggle switch, or I shift the toggle switch a little bit inwards. We can try this as well. Set it to 15. Oh, okay, I have to. Maybe a little bit more. Okay, that's the right spot. Down position, top position. Now I have to cut a hole inside this boss or a little pocket where the toggle switch can reach into. So now you can either go back to the swivel axis and do it in here, or you can do it in the assembly. I'm capturing the position in the end stop. All right, capture. And now, right next to this component, there is this pencil, and the pencil is an edit in place. Okay. And now all the other components are grayed out. It's like you're modifying the swivel axis in this design document, but this time you can create a sketch as usual. No, that's the wrong plane. And you can project some geometries like this toggle switch. So I'm starting with creating a line right in the middle, and then two other lines symmetric to the center line. And right now, I will not cut it to the full size. Now that's still a collision between the toggle switch and the bus, but I will remove the remaining material later on just with a file. So it's much simpler that way. When I finished with edit in place, just hit this symbol and you're back in the main assembly. This looks good. Here, some more material to remove later on as well. Well, that's totally fine. Okay, back to the wall left. That's revert position. That's okay. I have to create a little bit space for the nut of the toggle switch. Now I created a little pocket for the nut. And this should be fine. Now the toggle switch is in place. Let's go back to the main assembly. Both of the walls. Deactivate all of the sketches we don't need anymore. Okay. The next step, let's add the potentiometer. Where is my, here is the pedestal, Speedbrake, sub-assemblies, and in here is a potentiometer, drivetrain. But I don't want to open it, just drag it into the assembly. Right. And create a joint. Here to there. If necessary, flip it. Let's check the alignment with the remaining parts. This looks already great. Oh, what's happening here? Let's go back to the joint. Let's remove the offset, flip it, and 20 millimeters upwards. Okay, that's too much. But for the right alignment, I can either change the offset until it fits, or just add a slider in the Z-axis. We can just slide it upwards. I don't care about the position of the holder right now. Well, now I'm just adding another constraint between this face and this face. And now it's connected. Let's go back to the joint and rotate it by 180 degrees. Okay, let's change the relationships, the joints, not in the toggle switch, in the potentiometer. There are the joints. Let's start with the first one. Set it to 90 degrees. And the second one, drive joints, there's an angle. Set it to 0 degrees, and now it's aligned perfectly. And we have to create a little boss for the potentiometer mount. For this, simply go back to the wall left, create a sketch over here. Of course, capture the position, very important. Project the geometry of the slot as a construction line. Two-point rectangle, symmetric constraint to this line. The height 12 millimeters, the width 20, and right in the center circle and a polygon. .5 millimeters and 7.2 for the polygon, create an extrusion with this profile, and a second extrusion with the polygon from this object 2.5 millimeters into the part. Add some fillets. Go back to the assembly. All right, now the gear or the drivetrain is in place. All what's left to do is to create the axle that's linking all together. Let's close the other components. Okay, new component, the axle. And here I'm starting with the swivel axis to move it back into a neutral position. No, it's not in the swivel axis, it's here in the relationships. The first one, edit joints. Drive joints, there it is. Back to 0 degrees. Create a midplane. And on this midplane, I'm creating a section analysis. Now I have this profile, and on this profile, I will create a profile for a revolve operation for the axle. Go back to the axle, make it active, create a sketch on this midplane. And now I'm creating a profile. Something like this. Okay, now let's add some constraints to the center. This one is aligned with this part. Oh, there's one step missing. Like this. This is aligned with this line. This is aligned with if necessary, just create some projected geometries. Okay, now the main diameter of the axle from the center to here, diameter. Dimension, set it to 20. And as I just see, I have to enlarge this diameter in here where the ball bearing is located. I'll do that in a minute. Okay, then this little ring, let's set it to 1.5 millimeters. And the diameter over here, I set it to 10. Now that's my main profile for the axle. Finish the sketch. Revolve this profile around this axis. Okay, this is the main contour of the axle. Let's open up these two diameters, go back to the wall left, switch off the axle, create a press pull for both of the faces. Go back to the axle. And now there's more space. So this ring is aligning with the right face of the bearing, and it's pressing the bearing onto the middle section over here against the other bearing. And now I have to create a ring over here on the other side, but I could just go back and change the profile over here. 18. Yeah, and I have to create a boss for the polygon over here. Create a sketch on this face. Create a polygon, circumscribed. It's 10 millimeter, but let's give it a little bit of space. Set it to 9.5. Create a boss with this profile, 5 millimeters. It's important that it's underneath this surface because I want to press this gear with a bolt onto the axle. Create a hole right in the middle. With a thread. Metric profile, 8 millimeters. And very important, it should be modeled. So it's cut right into the axle. And later on, with a washer and an M8 bolt, just press the large gear onto the axle. And I have to create some more press pulls. You will see in a minute why. These two faces. No. Let's give it 2 millimeters. this 1 millimeter. Create another sketch, for example, on this plane. Now it's, I admit it's a little bit confusing, but you will understand in a minute. Create some projected geometries. This one. And a larger one. .22 millimeters. And now create an extrusion with this ring. Object from here to there. And a new body. And create a press pull with the inner surface. Okay. Now what's happening? In the pockets there are the two ball bearings. So with a screw and a washer, I'm pressing this large gear onto the axle. The axle will grab the this ball bearing, pressing against the center segment. The center segment is pressing against the other bearing. Then this little ring is pressing against this gear, and everything is fixed together. So this should work just fine. All right, let's go back, switch off the visibility. Create a chamfer in the back. And because there is this rod in the middle, I have to cut away or cut a hole all the way through the axle. That's very important. For this, I'll just isolate the axle and create an axis. And on this axis, I can plane at angle 0 degrees. And on this, create a sketch. Bring back the swivel axis. Project the geometry, the 8 millimeters. Set it to 8.5, just a little bit of space. These two profiles. Symmetric, all the way through. Create a chamfer. Like this. Now I've created the swivel axis, the drivetrain, the axle, everything is connected together. All what's left is to mount it to the panel itself. So I have to create a cutout in both of the panels and create some screws for the walls. Let's cut the holes for mounting this whole assembly together. It's actually pretty simple. Just go to the bottom of the panel, create a sketch over here, and in there just project the circles of all the mounting holes as a construction line. Okay, and in there finish the sketch, create a hole with multiple points, switch back from tapped hole type to simple with a counter bore on top, lower diameter 4.5, the height of the counter bore 4.5, outer diameter 8, and 10 millimeters in height. And just if you want to, insert a fastener, bolts and screws, socket head. I'm using the socket head with a DIN 912. Just pick one of the inner diameters and Fusion will automatically recognize the size. It's M4. And set it to M4 by 20. Hit OK. And now he created the screws. The screws are located in the bottom component. All right. Let's create a globe or a sketch inside the panel. I'm using it for both the top and the bottom. So select the main panel, create a sketch on top. And now I have to create a slot in there. Just project one of the geometries. Create a slot. Center point slot from here upwards and open it up, but as a regular line type. Or change it back. Okay, the length of the slot, set it to 50 and the width to 15. And now let's tilt it back to the end stop. That already looks great. A little bit of space over there. All right, let's go back to the sketch and create an offset. 1 millimeter is enough. Activate the top component, create an extrusion. Another extrusion with this little profile over here. To object the bottom panel, but set it to join. And another extrusion at the bottom. Objects to cut, just the bottom. All right. Now I've created a wall all around this slot just to prevent light from the backlight bleeding through this slot to the outside. Okay, and maybe I will just decrease the width of the slot, go back to the sketch Set it to 12. Okay, failed to solve. I just want to have this slot as narrow as possible. So maybe let's change it to 10 millimeters. Okay, let's tilt it back to the end stop because I changed the width. I have to increase the length a little bit. So to 55. Okay, perfect. There's enough space on both sides. There's no collision in the middle. Okay, all what's left to do is to create the labels, but for this I will speed up the video. We did it so many times for the overhead panel, so I will not go into much detail about it. I will just speed up the video and create the labels. One more thing to finish the sole assembly. I want to make it a little bit more rigid on the lower side, so I want to connect both of the walls, the left and the right one. Go back to the walls, create a sketch on one of the walls, and then here I'm starting with creating a center construction line. Two circles. The inner one is 4.5. The outer one 6.5. From the bottom 4.5. And from the left edge. Now let's go back and make the sketches visible. Create an extrusion with this inner circle. Objects to cut, both wall left, body 1 and 2. Maybe I should change the name to walls. Okay, and now let's create a mirror of this feature. Mirror plane. This one to the other side. And between both of the walls, I want to use a little tube. You can either cut one piece of the 6mm tube to the right length, or I'm creating a little tube and just print it object from here to object there, but create a new body. I will print this little tube 2 times and connect it with some long screws. Can go back to the fasteners, add a washer, plane, and a regular one over here and over there, but not this one. I just deselect it, create and continue. Go back to the fasteners, bolts and screws, socket head, M4x40, and apply a nut, hex, and I'm using the self-locking nuts. Over here. Okay, and now it's a little bit more rigid on the lower side. Now the Speedbrake is ready for printing. Now the next episode we will do the printing and the assembly. We are at the end of this video, and as you have seen, in almost 2 hours you're able to design a whole assembly like the Speedbrake in Autodesk Fusion. For sure it requires a little bit of experience in Autodesk Fusion, and if you have done some assemblies it will get much quicker, but I hope that you have a brief overview on how to create assemblies and how to use joints in Autodesk Fusion. In the next video we will do the assembly of the Speedbrake. As I said in the introduction, all the printing data for the Speedbrake is available on Patreon. If you found this video useful, please give it a like. If you are new to the channel, please subscribe and hit the bell, and I hope to see you in the next video.